Hello everyone and welcome to Handmade Hero. This is the show where we code a complete game live on stream, although today what we're actually coding is the thing that will produce font bitmaps for our game. So technically it's not in the game. It's a little offline utility to shove fonts into bitmaps so that we don't have to do it ourselves. I guess technically we're doing it ourselves because we're writing the utility, but you get the idea. So the point here is pretty basic. It's just to say that, look, we need fonts in the game. We want to be able to have those fonts edited in a normal font editing package so that either we can just take free fonts that we want or purchase a font from a font foundry that's been made by a professional font designer and then turn it into art assets we can use in the game, or we would like to be able to make our own fonts in a font creation utility. But either or, we want to leverage that existing technology and not have to make like our own font editors or force our artists to create some heinous list of font text markup something for kerning, who knows what, right? We want to use the existing tools, so what we need to be able to do is take a TTF file or an OTF file and turn it into a series of bitmaps automatically, and remember all the kerning information that goes with it. So the goal of this font utility is just to take that information, dump it out, so that it can then be loaded on demand as any other art asset would, and packed into HHA files as necessary as any other art asset would. And that is our goal. So if we go ahead and load up where we were, because we actually did a bunch of this work last weekend. I think we took a day to do it or 2 days to do it. I don't remember how long we've worked on this. It was either 1 or 2 days. But point being, if we go look at where we were at, I think we got right to the point where we just sort of did the flow of the code. And you can see this utility here. It's pretty tiny, right? And it probably, I'm hoping it won't be too bad because there's not that much stuff that it needs to do. But if you run it on the command line, you can see that we've gotten the basics started. It lists how it's used. You run the HHFont utility. And then you say which TTF file you wanted, what the font name was inside that TTF file, because I think TTF files can even potentially hold more than one. But either way, we kind of have to do that because Windows doesn't really let us figure out what the fonts are in a TTF, I don't think. We have to basically say load this TTF and then query a font by name out of the system. We can then go to the next parameter, which is pixel height, which says, okay, how big did you want to generate this font? Because obviously TTF files store vector fonts, so they're not at a particular pixel height most of the time, right? You can store bitmap fonts, but nobody does anymore. And then finally we have the char set, and that's just a thing that we have defined ourselves. And what that is that's a keyword, and you can see it listed here. Test is the one we have defined so far. And what that is says which characters to extract out of the font. Because remember, depending on who's using this and where, let's say that a Chinese person wants to extract a font for Cantonese or Mandarin or something, right? Or, I don't know, maybe simplified Chinese is the thing that everyone's standardized on now, right? But point being, they want to extract those glyphs. Now, those glyphs are a different set of code points than the glyphs you would extract if you were, say, German and wanted all of the German glyphs out of a font, right? And those would be, the standard characters that we use in English, and then also some of the, diacritical marks and things that are, accents and things like that German has that we don't, for example, in English. So you need a way of extending the font utility to say what ranges from a font you want to extract, and that's what that keyword does. At the start, we're just going to support English because that's the only language I really know. My Japanese is terrible. And my French is, also terrible, but probably not as terrible as my Japanese. And so I'm not going to try to do any foreign language support beyond simply making sure that our font system supports it for people who do want to do it. And then we can, move on from there, knowing that when the time comes, if we want to localize Handmade Hero into some other language, we haven't shot ourselves in the foot by hard coding our entire system to only extract one language's fonts, whatever those might be. So that's the goal there, is to make it extensible so that as you want to localize things from country to country, you can easily extend the set of glyphs that are extracted from a font pretty trivially. So that's what we're trying to do here. And furthermore, we can use different fonts. So, it's highly likely that the font that we use for English language wouldn't necessarily be the same font that we might want to use for Japanese language and so on, because we probably will find, certain fonts are better for certain languages because the person who made that font was targeting a particular language for it, right? And this is especially true of other things. Most fonts, for example, that are made to be English language fonts probably don't have any glyphs at all for Thailand, for Thai language, or, like, let's say, glyphs for Vietnamese or Korean, right? They're not going to go out of their way to create characters for languages that they weren't targeting because they probably don't even know how to read those languages or what would make a good font. So you probably have to pick different fonts for different languages if you want high quality glyphs. There are some fonts out there that are designed to support all languages, but those might not be the style that you want, right? So you kind of need to be able to go and pick different fonts for different languages, and you don't want your system to be constrained such that it has to use just one font and that has to cover all the languages, because that may limit your options for creating richly styled fonts in various languages. Or, the people who try to read, your game in Farsi or something are like, this font looks terrible, and you want to be able to fix that, but you can't because you could only use one language, one font for all languages, so you got to keep it to like the few fonts that actually support them all, etc., 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 right? So the goal here is to allow that to be flexible, so that basically as we want to localize the game, should that occur, we can make intelligent decisions based on feedback from people who are actually native speakers to that language. And if they say, this font looks a lot better, we can use that font for their language and some other font for someone else's language without having to make that trade-off of, well, it gets worse for one, better for the other, blah, 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 right? So that's the idea there. And let's go ahead and see where we're at. So if you look at what's going on in this utility, what's happening is when you pass all those things, we first run that char set, like we made it easy to add those char sets. We run that char set code, which basically says, look, put in these ranges of characters. You can see here we include the space character, we include the full set of typical ASCII, right? And then we also added some special code points. These code points are for the kanji characters for owl. And that was just testing to make sure that we could handle high, like 16-bit UTF. You can see these are values that require the full 16-bit range of UTF-16. So we wanted to make sure that we could actually call some 16-bit characters out of Windows and get them. Obviously, we can't use anything higher than UTF-16 because Windows doesn't support it. Although Windows 10 might start supporting it soon. I don't really know. But anyway, to be able to extract those fonts out, that's what we were trying to do there. Getting that done was just a test to make sure our system worked for those fonts. So this will create a mask that says, here are all the glyphs you should export. That then allows us to call our extract font routine. And our extract font routine, if you look at it here, goes through each individual, excuse me, goes through each individual glyph and tries to extract it. Now, what we haven't done yet is actually do anything with this data. So you can see right here, we've done a load glyph bitmap. That actually rasterized the font. We have the font ready in font bits to export. We also have filled out our entire horizontal advanced table by the time we get to the end of here. So technically, when I do this, if I was to run this and say, hey, and I think we had a thing down here that actually sort of gave an example command line. So if I was to actually do, let me extract. I don't actually know what we're extracting. Is it Liberation Mono? I don't know. So if I was to actually follow the instructions here and actually supply, one of these things here, that in theory should actually do the full font extraction. So in theory, this is actually doing it now. So all we need to now add to our system is actually export the data. Now, the easiest thing for us to do would be to steal the bitmap writing code, write out bitmaps, and then just have a thing that writes out the HHA that corresponds to those bitmaps. We're going to start with that. I don't want to leave it that way, and if I can get that all done today and it seems to be working, then what we'll do is tomorrow we'll start on PNG export, because what I'd like to do is just keep these all in PNGs so that the game doesn't have to have 2 export paths, one for BMP, one for PNG, right? So I'd like our utility to export PNGs, not BMPs. We don't have to compress them. We can leave them uncompressed, but we should write them out. So if you look here, you can see the extraction. It says I'm going to extract 100 glyphs. The largest code point is 32820. That's going to correspond to like probably this one here, right? 8033 there. So, you know, make of that what you will. In theory, that actually did all the extractions, but we never actually wrote them anywhere. And so that's kind of where we're at now. So let's start by trying to dump these bitmaps somewhere. What I'd like to do is expand, you know, I know it's already kind of way too many parameters to this thing, but hey, that's just how it goes sometimes. What I'd like to do is create 2 more pieces of information that go along with this. I'd like to say I want to know where to write the output. So, you know, a dest HHA file, I'm sorry, not a dest HHA file, a dest HHT file, so like what tag file you wanted to write out. And then like what directory do you want to dump the pings? You know what I mean? So this way in here I can say, give me all of that. So I want to know 2 things here from 5 and 6. I want to know the like HHT file name, and I want to know the PNG dir name. And right now we will be writing out not PNGs, but actually bitmaps, but we'll change to PNGs when we have a chance to finish to do that code. So if we call extract font here, this is going to need to take care of that. I might save the opening and writing of that HHT perhaps to out here. So maybe we'll first try to ensure that we can actually get it. So if I was to say like HHT file equals fopen, and in here I'd say that I wanted to do a binary write of this file. Now technically we're actually writing it in text, but I hate the text mode in the C runtime library, so I just never open things in text mode. So what I want to do here is say, look, give me the HHT file names, file there, we're going to oops, that's not what I wanted. We're going to open that up, assuming that we could get it, then we'll just pass just the handle to this, so that instead of passing the file name, we'll actually just pass a file that's ready to be written to. I just like handling that outside a little bit better. And then finally, we'll pass that PNG dir name. So we will pass that because it's going to have to generate file names in there continuously, one for each bitmap as it goes. So I need to print out an error because we may not be able to open that file. So I need to be able to do like error unable to open HHT file this for writing. And so, oops, HHT file name. And that just lets the user know if there was some problem with writing to the place they told us to write the HHT. And then I could go up here, and inside the extraction code that's trying to actually extract this font, I can have the HHT out, so that'll be how that's written, and the PNG dir, right, where that's going to be. Now, we don't really need to close this file because it'll get closed automatically, but you know, I'd like to just keep it clear what's happening here. So I'm going to go ahead and do an close on this just for good measure. Again, don't really need to do that technically, but we should. And just to make sure it's flushed, right? I mean, I don't really know what the rules are. I don't know if it auto flushes streams when you close, but you know, just in case it doesn't. So now coming through here, this is where we want to start doing that work. And so we need to start naming these, and I think what we want to do primarily is just give them names that probably are associated with the font, I would guess. And so if you look in here, you know, you can imagine some ways we could name it. I'm guessing what we should probably do is use the stem name from the TTF. So maybe like just this, like this part of the name. We could use this part of the name, but the problem is that might have spaces in it. Now, we could sort of... we could get around that by replacing those with underscores. That seems probably more reasonable. So maybe after we actually create that font, maybe that's how we want to do it. That seems kind of reasonable to me. I think that's probably how it should go. So coming up here, if you imagine how we would do that, once we enter here, we have the font name. And what we would like to do is create sort of like a font stem name there, or I don't know how you want to phrase that exactly. But I would like to be able to create something like this, name stem. So all I'm going to do is I'm just going to create a buffer that happens to be the same length as the font name itself. And then what I'm going to do is I'm going to force that to be like something that doesn't have any spaces or anything else in it at all, right? And so what I want to do is say, take the font name and like pass it through to the name stem here, so that we know that, you know, it's all cool. So let's just do something real quick here where we say, you know, source dest, and all I want to do is just say, well, I guess I can even do it this way. Yeah, I guess I'll just do it this way. I guess I'll just say, look, while the source equals something, we'll just copy it, right? Now, I don't quite want to do it exactly that way because I'm going to need to be able to check. In here, I would like to make sure that we copy the null terminator. I mean, one way I could do this is since I know it's null, at that point I'll just write it. But while we're doing the sanitized pass, what I want to do here is say, look, if the destination is, you know, I don't know how I want to put this. I think, okay, so I think what I'd like to do is let's just convert it to lowercase first, right? So we'll make sure it's lowercase, and then if it's not in the range of like things we accept, so meaning if, you know, star dest is greater than or equal to a, or I should say, and star dest is less than or equal to z, right? So if it's within the range here, and you know what, let's even do this a little bit squinkier. What if we do this? So what I'm going to do is say, all right, if you're within the range of characters that I accept, so if you're like this, or this, then I will allow it. If you're not, and I don't know why I didn't just use the character that I extracted there, that's what I wanted. So if you're in the range of characters that I accept, then we will use you directly. Otherwise, we will stick an underscore in there. And that way we have a name that we know is kind of completely without weird stuff or spaces or anything. So it just gets cleaned up, and that way all the names of our bitmaps don't have like weird garbage in them or whatever. So what I'd like to do now is just say, all right, let's say we sanitize that name. Now what we can do is produce bitmap names on demand. We know like roughly how big we need that to be, meaning we know that we're just going to use the sanitized name plus the PNG dester plus, you know, like the code point number and so on, right? So we know how big this thing needs to be in order to make a buffer that can hold our file names. So, you know, we know that we need some size here. That's going to be the size of the name stem plus the size of the PNG dester, right? Plus we're going to need a slash, and we're going to need .png, and we're going to need all that stuff, right? So let's just give ourselves plenty of pad, right? There's no chance we'll exceed that, so we're just good to go. Now anytime we want, we can just say, fine, let's sprintf into the PNG out name what our name would be, and we know that it will look like this, right? It'll be %s%u.png, right? And we may want to do this into 2 buffers because we may, well, I guess we can just use an address for this, so I guess we don't really need to do that. So we'll get to that in a second. But so if we do the PNG out name here, what we want to do is just say, okay, we'll do the PNG out name. We'll create that by saying whatever the dester is, we start with that. We then go to the name stem, which allows us to fill in, what the start of the name should be. Then we would have the code point, and off we would go, right? Now, if we want this to be padded, we could also say that, which probably makes sense. So maybe we'll just leave it that way. This is going to be per glyph. So here's us going through each individual glyph to write it out. So once we get that code point out, this would be what would create the actual name here. Furthermore, I think we probably also want to do like a PNG stem. The PNG stem actually is just the length of this thing, right? So whatever PNG out name is, it's just the length of PNG dester plus 1, because you're going to skip that slash. So we probably could just do this as well, right? So here we just say this is the part that's like not the dir, right? Maybe that. And we're going to need that for writing to our HHT. So what I want to do now is just start testing this out a little bit. So what I'd like to do at first is let's just write out, we know what this should look like, right? Let's write out something that is commensurate with how we have done our HHTs in the past. So here's our tags files, here's our HHTs, right? This is what they look like. So what we need to be able to do here is just put all of our bitmaps in here. So what we want to do is maybe call these glyphs so that the loader knows that they don't need to be marked up by anything. So in here we would say, okay, we want to output a glyph, and then we want to output that base name, like so. And so we're going to print this out to a file. It's going to look something like that. And this has to go to our HHT file, right? Sorry, HHT out. So I think that's correct there, yep. So we don't really need anything in the brackets. So I think the glyphs can just literally be that. So we just say glyph name and then nothing. That lets it know that it's supposed to be imported, probably. I guess we may need something in here that says which code point it is. I'm not sure. Let's just say that we have to do that. So maybe we'll do glyph index equals %u. And so in here we will put whatever that glyph index actually is. So it basically just says, hey, this is for a particular font. This is going to be this particular glyph index, right? And we also could associate this with a specific font. I guess is another way to do it. In fact, we probably should do that. So maybe we put the font name in here as well, right? Just so we know what that font name actually is. So that seems like another good thing to do. So maybe in here we have like font or name stem, right? So that name stem right here gives us that information. I think that would work. So then what we can do is, push all those glyphs in there. And again, I really don't know what the best way to do the packing for this is. I mean, there's another way we could do it. maybe this is better. See what you think of this. So what if we said, oh, here's a font, and we tell you what the font is, right? So we say it's this font. Oops. Then we say inside the font we list the glyphs. I don't know if that makes more sense because they're so specialized. And that would look like this. And I really don't care what this is right now. I think we can adjust this pretty easily once we go to do the reader for it. So I'm just going to do whatever here. Let's just say this will work. So here's the glyph index. There's the PNG file only bit, right? That just lists all the glyphs. And then we close it out, and that's the end of the font, right? So that seems good to me. And then we can also, if we want to, we can put this in here. Like maybe when we start writing this thing out before, when we actually create it here. Oops. Maybe we can do something where we just do so that'll just print a boilerplate in there. And since we don't really know what the copyright of this would be, I don't even know if anyone knows what the copyright of that would be. That would be interesting. Because you can't copyright fonts. So extracted fonts, I don't think you could claim that you copyrighted it because you haven't done anything. I mean, so presumably it's still not copyrighted, but I don't know. So anyway, point being, this would just kind of, put a header in there for us. And off we would go. And maybe we could even do this. So what exactly was the name of this font again? Is that Molly Bean? Is that Molly Bean? Come on up. Come on up. Come on. Oh, come on. You can, it's such a small jump. There you go. Hello. How's it going? What you up to? Huh? Did you come to help with the code? Are you going to help with the code? What do you think? What do you think of this code? Do you think it sucks? Yeah, you don't like it, do you? It's not good enough. Do you want to look out the window? There you go. You can look out the window. That's a good girl. All right. So if you take a look on here, right, we're just basically saying, let's go ahead and, oh, you know what? And this can probably bake in the actual name as well. So this would be arg0, right? That's the name of the actual program. So as this goes through, it should now write out like the data for the font. And furthermore, like in here, as we're writing these glyphs out, we're building up the horizontal advance table. We can then dump that table when we get to the end. So we should be able to say, okay, here's our horizontal advance table. Like so. And this is just, you know, this would just go in and I guess it's, what is it, a squared table? So we should be able to just write it out as one giant list, right? So yeah, it's just glyph count cut. So you know, I might store that so that we can just know that if we're gonna write out everything in the font, it would look like that. And so here I'd just say like, all right, and write them all out. So I think these are floating point scaled actual advanced numbers. I don't know how much precision we want there, but I'm going to go ahead and say we probably only want 3 digits of precision there. This is not something that we could really use beyond that, I don't think. If index, we need to print, well, actually, I guess I'll just do it this way. The height of laziness, ladies and gentlemen. I'll just say if index, then put a comma, otherwise don't. That'll keep it comma separated. And then we just need to say, all right, horizontal advance of index, print that out. We get to the end, we'll stick a semicolon and a carriage return, and we'll be done. Right? Molly, no, we don't scratch the molding. Okay, that's unproductive. Why don't you go to your tree? Here. There you go. I gotta brush you. I gotta brush you. Look at you shedding. God, I brushed you so much the other day, too. I think it's your new coat's coming in. You're getting rid of your undercoat. You're getting rid of your undercoat for the springtime. You're going to be nice and cool for the summertime. Yeah. That's a good kid. You gonna spot some crows? Maybe a seagull? I don't really see much out there, but maybe there'll be something later. All right, so that's really all we need to get started. And oops, so to lower, what's the problem here? Oh, right, this comes in as an int. So let's see what else we got. That needs a file. So that should start now giving us at least something we can start working on. So if I say this, it should give me an error. And now I can say like, okay, do I have a temp directory here? Yeah. So let's make dir temp font. And we'll just say like, okay, we need to provide a dest HHT. So we'll say temp font test.hht. And then here we'll say temp font. And we'll hit return. We'll see what we get, right? So now if I, for example, do wtemp font test.hht, here's our font file. So there's all of our glyphs. Doesn't look, where's the, that might have been because of the fact that it's not actually a tabbed file. Yeah, there we go. So here's all our horizontal advance table, right? So it looks like this is always in even pixels for some reason. Why would that be? Shouldn't that have been a floating point value? That seems a little strange. I mean, aren't we scaling that value by something, or are we literally never scaling it? That's pretty interesting. So I guess we don't ever scale it. So that's always a pixel value. It looks like we're not scaling down, which that doesn't make any sense.
So are we not scaling at all? Oh, so I guess we're letting it do anti-aliasing for us? Fascinating.
Well, all right, then I guess just don't need to do that. Didn't realize that we were always on pixel boundaries here. So I guess we're actually just doing that. And I don't know why we're storing floats in the first place. I guess just, you know, so I guess we don't really have to worry about that, and that's fine. So this looks like it's all outputting exactly what we want, so I think now we can move on to just worrying about putting the bitmaps out, right? Now this is not a particularly pretty way to print this, and one might argue that we should probably try to make it look nicer. And we certainly could do that. So if we wanted to do that, we could just go ahead and do some kind of a, you know, strided version of this. So for example, we could say something like, you know, if index and index mod 16 equals 0, so like every 16 times through the loop, we will actually do a fprintf. And you know, we could do this even. Takes away some of my fun, but you know. Oops. And what this would do is say, all right, look, let's every 16 numbers, instead of doing this, what I was doing here, let's get rid of that. And what we'll do instead is say, okay, every 16 times we'll actually print a carriage return and start printing on another line, right? So here we'll do comma and then carriage return 1 2 3 4 1 2 3 4. And here we'll just do, you know, just the comma, right? And you may be asking why I felt the need to put that up here. Well, yeah, I mean, I guess I didn't really have to. I probably could have still kept it in a more inline way, but I felt like I shouldn't do that, so I didn't. Anyway, so that would be like just a nicer printout is all that's doing. It's not changing. It wouldn't change what would happen at all. But then, you know, if I run it here and then type that out now, type wtemp font test.hht, you can kind of see, right, it's just like outputting it in a block of text. And, you know, we could make sure the block always lines up too by just saying, like, look, make sure all these are always 2, because that's generally what we have for advance. We could even make them 3 if we wanted to leave some space for larger fonts, which we probably will have at some point, right? And so there's like, now it's just printing it out in a block, and that's just like a little nicer to read. That's all that is. And so that's like probably it, right? This is probably legible. I'm going to make this horizontal advance do a carriage return. That's actually, we could sort of factor that out. I guess probably the easiest way to do it is literally just do it here instead. Right? We could just do it like that. I think that might look a little better. Let's try that. Yeah. So that seems good, right? There's our horizontal advance array. So now that whole thing is just in there. This needs a closing semicolon, I think, right? So that should be there. And that's it. So now I think we can move on to just outputting the bitmaps. We know where we're going to put them, which is right here. So now we need like a thing that's like write PNG. And the glyph result that we have here, that should tell us, like, that's this right here. that should tell us what we actually need. Now, this extra data has to be stored into the glyph somehow, right? So I think that align percentage has to be in there. But I think that's the only piece of information, right? It's just the align percentage. So that would have to come in here, meaning it would have to be like, I don't know how we want to do this, but it would have to be something like that, right? And I don't know, I don't really remember how we were looking at that piece of information before. But that is something that has to sort of be written out. The align percentage has to be put back into the file when it's actually being exported, right? So let's just do it this way for now. We'll see what we want to do later, but that's align percentage X and glyph align percentage Y. That's the alignment of this particular glyph. That seems fine. And then we now need to actually write the PNG out. This glyph result doesn't actually give us what we need for that. So we need to actually return that as part of this load glyph bitmap unless we pass the writing context to it. But I don't think we want to bother with that. So we want to be able to say here, write a PNG to this file name, right? And we want to be able to say what the width is, right? We want to be able to say what the height is. And then we want a pointer to the pixels. So we need, like, you know, we probably would also need a stride, although we may not need a stride. I'm not sure if these things are tightly packed or not. So we probably can just look first and see whether we need to, whether we need to support a stride or not. So let's take a look and see how this gets packed. Out pitch is, no, it's packed. So we don't actually need that. And then that out, that piece of information there for the out, where is that actually coming from? So we're just mallocing the memory for that, right? And it's this right here. Now there's really no need for us to malloc that every time. That's just dumb. We could just have one piece of memory that we pass in. And I think I would probably prefer that because there's no, like, there doesn't need to be any mallocs in here. At least I don't think. So if we look at, if we look at where the mallocs are, yeah, there doesn't need to be any mallocs in here. So what I'd rather do is say, okay, let's go ahead and have out memory be passed in. Out memory can just be like the biggest the thing could possibly be at any particular point in time. And you can kind of see, like, max, like, we know that this is the only size we have for writing to the bitmap in the first place. So it doesn't really make any sense to do anything other than that. Right? That just doesn't make any sense. So whatever the max glyph dim is, that's all we need for our actual size. Now the font bits presumably were getting created here. Yeah, here they are. So all we really need to do is say, look, the out memory is just going to be whatever the size the font bits is, right? Because that's also that size. And so when we create what that maximum has to be, and we know what the maximum is because we're passing it, right? We're passing max glyph dim, so we must be setting that somewhere. Yeah, it's right here. So here's the max glyph dim, right? So immediately after that, we should be able to say, well, just take the max glyph dim X times the max glyph dim Y times whatever the size of a pixel is, and that's it, right? You're done. So at that point, you can just say, all right, let's go ahead and pass that every time we extract a glyph, and now we're not allocating memory every time for no reason, right? All right, so at that point, I think we don't even really need to know what the pixel pointer actually is because we already kind of know it, but I'm going to say let's return it anyway just because why not? So in here, we'll say the glyph result includes the pixels, and it includes the width and the height of the thing. Then inside this particular function up here, where we're going to pass the result, we just need to fill those out. That's irrelevant. And this should all just be known. So where do we get all this stuff from? So this is how we computed our width and height and all this stuff. I'm going to go ahead and say, look, this has outlived its usefulness. So this is actually going to go up above now, which I'd kind of toyed with doing before. So that'll go here. And then this stuff can just be filled out inside. So when we do this, you know, there's the out width, the out height, the out pitch. We clear the memory and so on, and all that nonsense. So what we want to do now is say that we've got the out memory, we've got the out width, out height. So now we have all of that data, and then we just need a function that actually writes the PNG. You know what I'm saying? So that function, oops, is not going to do anything fancy. It's just going to take a width and a height and a pointer to the pixels and the dest file name. Obviously, it'll try to open that. And if it doesn't, so if like that file can't be opened, that's an error. So like we'll tell the user, just so they know it failed. Like maybe they typed a directory that doesn't exist for the destination or something. So that's all we need here. Now we just need to actually write the PNG out. And in order to do that, well, I mean, we could do any number of things, right? But I'd rather start by just taking, we've got in HHA edit, we actually have the thing for dumping the bitmaps in here somewhere, I think. I hope. I don't actually know where that is. Here it is. So in here, we can just say, look, let's take this header, dump that in here. You don't need that. Here's the right image to top-down Rgba nonsense with the pixel ops nonsense. And let's just go ahead and run that. I don't think we need to touch it at all, though, do we? Because we've already done all this. So we can actually just kind of do this. There we go. We don't need any of this stuff. Because these are monochrome, right? So we don't care about inverting. We don't need to do any other stuff with them. So we're literally just writing these out one at a time. In fact, this whole loop, this whole thing is not necessary, right? We don't need to do any of this. So we can literally shorten this, I believe, down to just that. So we can just say, look, write these two things and be done with it. So I think that should do it. And of course, this won't be writing a PNG. It's actually a BMP. But we can start there, right? So now let's actually try this and see if everything just dies a horrible death. If I go into that temp directory and I look at the fonts here, then I mean you can basically see that it worked okay. I mean there's the font, right? So I think we're good to go. That's all the stuff that we had wanted. And I don't know what this is. Looks like this is one of them is probably had nothing in it. But that looks like all the stuff in the font. I don't see anything weird going on there. So that all seems fine, and in theory, we should be able to change the size or something, and it should get significantly larger. So like, let's say I did this, and restore. There's bigger fonts, right, dumped out in there, and looking at it, it looks like, I guess, roughly what we would expect to see, maybe, right? So that seems fine. Now what we need to do is we need to actually write out a PNG, because this is a BMP. And so I don't know how much time I've got left. Actually, I guess I have quite a bit. I think I have like 45 minutes. So I may go ahead and actually start on that. So in order to write a PNG, what we need to do is reverse the PNG spec that we were using before. And instead of trying to read one, we now need to write one. So I'm going to go ahead and open up our PNG reader here and just look at what we read, right? And see what's up. So if we look at the actual routine, what's it expecting to see? So we're going to come in here and say, okay, let's read a PNG header. That seems easy to replicate. We're going to start reading chunks. The chunks are endian swapped, it looks like, which is really unfortunate. I forgot that PNG, is that really true? So PNG is always endian wrong. Where's endian swap? Yeah, so it's just always wrong. That's unfortunate. Anyway, so we gotta endian swap all our stuff before we write it out, because it's all gonna be wrong. It's all gonna be the wrong endian. But then we get, it looks like chunks. We need one that's an I header, and then one that's an IDAT, and hopefully that's it. I'm assuming we should be able to set the compression size to nothing. So is there an uncompressed compression method? Let's see. What structure was this called again? It's called the I header. Oh. Okay, so technically we have to have a compression method. Is that really true? So wait, is this, so if I want to write a PNG, all right, forget it. If that's the case, I might just add BMP and just say forget it, right? Because if that's really, I don't really want to have to write out all of this nonsense for no reason. That just seems dumb. Like, reading a BMP is not hard, so because I don't really want to write out a fake zlib stream that basically, I mean, it's not that hard because you just write out a zlib stream that's uncompressed, right? But it's still kind of annoying. Yeah, so it looks like
So the B type cannot be.
What's B type 0? Is there no B type 0? What's the There it is.
So it looks like if we just did B type 0 blocks, that's just pixel data, right? So in theory, we could do a thing that said the B type is 0, so there's no Huffman on it, right? So I guess we could do this pretty easy, because it looks like B type 0 doesn't have any Huffman on it at all. So in theory, we should be able to say where's that actually coming from? B type is consumed bits in the comp data. This is in the actual Idot header. Right after the Idot header is the actual data. Where's the jumpable part here? Come on. Let's see. Here we go. So yeah, I think all we do is just store them as B type 0. So all right, I'm okay with that. It's a little bit of a pain in the butt, but it's not such a huge pain in the butt that I'm not willing to do it. So let's give it a try. If we know we've got a file that has these spec'd out, maybe I'll just go ahead and try to include it. So if I come up here, like, can I just do this and say, you know, give us the stuff? It looks like that needs memory arenas. Why are those in here? Do these really have to be in here? Like, why can't they be... Is there a reason these can't be, like, down here? Does everything get destroyed? Oops. It doesn't seem like it. So we should be able to do this. This takes a stream as an actual hard-coded thing, so it looks like it does sort of need at least the definition of that. So that seems fine. All right. I think we're all good. Okay. So let's give this a shot. We need to start out by writing one of these things out. That's the first thing we need to do. So we've got the file header, and that thing needs to have the signature be that bit. I guess there's actually no reason to really do it this way. I guess the right way to do it, and let me just get rid of all this garbage. I guess the right way to do it is actually just write this, right? So write that out, the whole thing. That gives us a PNG signature, right? And I'm just going to work backwards here and try to produce this thing. Let's go ahead and look at the reader code and just try to do the opposite of what the reader code does, right? So we're just going to write out whatever this thing reads. So it's going to consume a PNG header. That's what we just wrote out. It's then going to try to start reading, and it's going to read a chunk header, right? So let's just start by writing that out. So we know we need a chunk header here. The question is what goes in the chunk header, and the answer is, well, a bunch of endian swap nonsense, right? So we need to basically endian swap these two things off of it, and we need to set them to something. Who knows what that is? Or that. Then it's going to try and read a chunk footer, and it's going to swap the CRC. Now, we don't actually use the CRC, so we don't have to write it correctly, but we may want to try anyway. Just to be able to be read by other programs that do check the CRC. But for our own ingress, we wouldn't have to. All right. So that chunk header is going to read the data for the chunk, which is some length long, right? And the only things we actually need are these two chunks. So we should then be able to write them and their footer, right? So, you know, this is what we've actually got. Excuse me. One of them's a ping I header, and one of them is just the IDAT chunk, right? So this would be the IDAT chunk here, and this would be the I header chunk here. So this, which I didn't even know you could do until Handmade Hero, right? I don't know if you guys remember, like, I was like, oh, you can do that? I didn't know. Like that's so cool. I had no idea you could do that. I just don't know when C added that, but that's pretty awesome. That you can do it now. So in here we need to specify a length that's going to be one of these long. Right, so we've got a ping I header. This is the IHDR that we're going to fill out ourselves. So we need this thing to be that long. This needs to be the type. Those two things need to get endian swapped. So, because we need to write them out in the opposite endianness, because pings, I guess, are Mac native or something. Or were. So we got to swap the endianness, which is a bummer, but we do. So we do that. And then we write it out, right? And so we're going to fwrite the chunk header, then the IDR, and then we need the chunk footer. And the chunk footer looks like all it's got. Does it have anything else in it? Oops. It doesn't. So basically we need a CRC. We're going to need a thing that does this, that computes the CRC. In order to write that out properly, because we don't have any way to do that right now, but we can. But anyway, then we would write out the chunk footer. So this is just going to be this. Oops. Right, there's some CRC here that we have to compute. Then we would endian swap it so that it comes out right. And then we would write it. And that would be the complete chunk, right? I don't know what the CRC is supposed to CRC. Presumably just the chunk data, but I don't actually know. So we'll have to actually do that. Then we need to endian swap any parts of the IDR that actually matter, which looks like a bunch of them. So we're going to have to set all this nonsense here.
Now, thankfully, we've got a little cheat code here because we basically know that we want filter method 0 and interlace method 0 and compression method 0 and color type 6, bit depth 8. So all that's fine. And then we also know that we need the width and height to be swapped because we obviously have those in larger. In the other endian, rather. So up here we would say, okay, let's prepare the I header. So there's the I header preparation right there. Oops. And there's the swap. Here's the chunk header. I guess that has to be done below here because it actually needs to know what the size of it is there, right? And there's the chunk footer. We then write those out, header, data, footer, and that's the complete header information that we need. So really the only thing that's probably wrong is this. Let's make sure we filled out this whole thing. Yeah, we did. So then what we need is we need the IDAT to actually contain the data like for the actual file. So we need to put the pixels into an IDAT, and we need the IDAT to have the right zlib header that tells it like, hey, this is uncompressed, there's nothing in it, right? So in order to do that, we need to do this again, right? We need to do another one of these fwrite nonsenses here that's got the header, header data footer, right? It's got to look like that. So now we need to do the same thing we did before, which is the chunk header now needs to be set up to be IDAT instead, right? And the length is not that. So we gotta think about what the length is gonna be, right? Because we gotta actually put, it's the pixel data, so it's gonna have however big it is, right? So then we've got like the chunk header. This needs to get written out first. There we go. So then we've got the chunk footer needs to have the CRC computed again, and so then the main thing we need to do now is fill out the actual IDAT stuff that's going to be in there, and that is going to require us to figure out, what that actually looks like. So at the very least, we need the IDAT header and the IDAT footer stuff to be correct. I'm guessing that this looks something like... I don't know. So let's go back to the reader and see what happens. So it's reading the IDAT chunks out of here, and it's literally just stuffing what's in the chunk. It doesn't look like it's doing anything else. So this just stuffs these onto the stream. That's all it does, right? Then we eat them out of here. So in theory, we should be able to just do it all in one and not have to do anything fancier, I hope. Because this is to support people breaking the file into pieces, but we don't actually need to do that for any particular reason. So this IDAT head here just needs this garbage to be set in some way that makes sense, right? So we just need it to come through and see, we basically need to see B final to be 0 and B type to be 0. So like the CM, the CInfo, the fcheck, the fdict, and the flevel just need to be like set to something that works. And so it looks like we're only supporting CM8 fdict 0, so we would just set that, right? So like whatever this needs to be for that to happen is all we needed to actually do. Right? The additional flags like fdict here is 0. Flevel, is that even used? So flevel is not even used.
So fdict and flevel, so additional flags can just be 0. zlib method is a composite of these things here, right? These two. What is the fcheck? We don't look at that. I'm gonna have to bounce back here and see what the fcheck is, because I have no idea. Is this the zlib stuff? So this is the zlib stuff. So unfortunately, we need the actual zlib info here. Oops. Guess it's not named that. So this stuff is all irrelevant. We just need to know like what the what are those flags? Are those flags actually specified in the PNG or not? So it does look like maybe those are in here. So where's the Idot chunk? So I'm not sure what that value actually means. So there's the zlib method flags and the additional flags. That's this. Okay. So deflate compression and some zlib nonsense we don't care about. So what are the additional flags in the check code? Like what are those? So it just does not say. So I'm not really sure what we should set these to. We'll have to find out because we're probably going to write this out wrong. So I guess I'm going to have to say, like, look, we know that the zlib method for CM is got to be 8. We don't know what cinfo should be because we don't use it. So we have to look up like what that should actually say because I don't know. But it looks like we want to set that to 8 to do so we want to find something in the spec. We should look a little harder after we kind of get through this. Just to find out like what else is supposed to be there, like because probably we should set those things to line up properly with what we're trying to do, you know, and I'm just not sure exactly what that should be yet. So we have an Idot header that goes in there, and then all we've got, it looks like, is we consume 1 bit, literally a single bit, and then 2 more bits, and that should be 0. So we want b final to be 1, right? Because we want to end. So we want to set the first bit that gets consumed, and we'll have to go see whether it consumes at the bottom or the top, because I don't actually know. And then we need to set the b type, so the rest of the thing needs to be 0. So we're either looking at setting the highest bit and everything else to 0, or setting the lowest bit. So it's either going to be that. Oops. That's not what I wanted.
it's either going to be just 1, or it's going to be the highest bit set, so it would be like 80, right? It would be like, like that, right? And I'm not sure which it is, so we got to go look at how bits are consumed and figure that out. But that's the first thing we want. That basically says, the whole thing, excuse me, the whole thing we're writing out is going to be 1 chunk, and it's not compressed, so have a party. So we then have a 16-bit length, which is just going to be our width times our height, and I assume times 4. I don't actually know if that's true. Yeah. So it's just a width times height times 4. It looks like these are written out in just a stupid way that's meant for checking for no apparent reason that I could necessarily predict. So I have no idea what the point of that is, but that's fine. So we basically have a len here. That's going to be width times height times 4. And then we've got nlen, which is just that. Right? So those... that can't write out something that's too large. So, meaning, we may have to break this into multiple chunks if the thing was too large. Don't know if we need to support, but that's the maximum we could do. Divided by 4 is that. So if we then square root it, that means 128 by 128 is the largest bitmap we could write out. If it was square, it could change, obviously. If we don't multi-pass this. So if we don't write out like multiple chunks. So I'm going to put a to-do in here just to make sure we know that. In fact, I could put an if in here, but I'm going to do it for now. Why they chose to write the length twice and have you compare the two, I have no idea. Instead of just having a 32-bit length, which would have allowed you to write the bits out directly, I have no idea. It seems incredibly stupid, but I'm sure they had some reason for it. I hope. I don't know. I would ask Molly, but she might be asleep. Anyway, so if we then say, okay, we're going to write out the length, that's how many there need to be, then we just kind of dump this out. I think that's it. And then that should just be it. I don't think there's anything else. So we need to write these two, right? Len and nlen. And then we need to write out the pixel data. And off we go. So don't know what this is. It's one or the other. So we'll deal with that later. But we have to write the stream byte. Then we have to write len, then nlen. Then we have to write the pixels, and then we have to write the footer. Right. Okay. So now we get to the thing where the length has to be included in here. And I don't know how big that's supposed to be because I don't know what it's supposed to include. Like, does it include the Idot header and the stream byte and everything else, and then the chunk header and footer, or does it skip the chunk header and footer because you already read those? We should be able to figure that out by looking at how we were processing it here. So what it looks like is we actually take the chunk data here, which is separate from the header, right? So I think it does not include anything other than this interior part. So the length that we're writing out is literally stream byte and then the actual length, right, which we just computed right here. I think that's what we're talking about. Where we essentially do like, okay, you know, take the IDAT, feed all the rest of this crap into it, and that's what we're going to be writing out. So then we need to figure out the CRC, obviously, which we haven't done yet. And then we just need to write everything out. So we need to write out literally what I just said. Oh, and we want this too. We want the Idot header, I think. No. Yes? Yes. That's also included. So the Idot header also has to go in there in addition to everything else. So then we just have a giant nonsense set of this crap where we say like, okay, and I could have built a struct out of this. Maybe I should. So it's a little bit simpler. But basically, I just have to write these in order. So you write the IDAT, then you write the stream byte, then you write the len, the nlen, and then you write the actual pixels. And then you stick the footer on there, and in theory, you're done. Now, in order to actually determine when we're done here, looking at this, you can see like we do a while loop until there's no more room in the file. So it looks like there is no closing chunk, at least not that we cared about. Now, in the spec, I think there was one, meaning there was like an I-end chunk or some crap like this that we are just not paying attention to, I don't think. But there might be one, and so we might want to stick that in there for compliance. Yeah. So just to be like a little more proper about it, I think we want to just dump out a completely empty one here. I don't know if it needs a if it's gonna have a footer. Take a quick look here. So it sounds like it. A 4-byte CRC calculated on the preceding bytes in the chunk, including the chunk type field and chunk data fields, but not including the length field. Okay. Why not? I mean, you knew the length. I guess it's because you want to write the thing and CRC as you go, and since the length came at the beginning, they want you to not have to have known it ahead of time. I guess it's stupid because you'd want to CRC the... Yeah, it doesn't matter. Anyway, so anyway, it looks like we would need a CRC on that one as well. So if we wanted to write that out, we'd be doing this again, like so, and there just wouldn't be any data in it. So we would say the chunk header, the length is 0, the type is IEND, and the footer.crc goes there. We would then, and you know what, I might start writing this a little differently, like maybe we write it like that. Right, because these are the things that you need to fill out.
So I think that should be good. And off we would go. That, in theory, writes a PNG. We need access to the endian swapping code that this is using, but that seems pretty tame. So what I might do is go ahead and put that up here so that everyone can use it, right? Did we also have it? Yeah, we do. Probably put that in the math library. All right, so who knows what this will do? Probably nothing good. But, you know, hey, we got started. And so tomorrow that puts us in a good position to start debugging that and getting it working. And because we only got about like 10 minutes left. So we probably won't get anywhere on getting this working, but at least we've got the we've got it sketched out, right? So here, so interestingly enough, it looks like we got some of it right? Because we have like the... Looks like the sizes are kind of correct. So we're not like totally off. So, you know, yeah. So, you know, it looks like our IDAT chunk is wrong, but our iHeader chunk is correct. Probably something like that. Meaning we got like halfway there. So that's good. So, you know, this probably came through correctly, but the rest of it didn't. You know, like something went wrong there. It would be nice if there was a way. I don't know if someone would complain about errors in the stream properly, like GIMP or somebody. Probably not. No one's probably going to say what's wrong with the stream, unfortunately. Right? It's just going to say it's corrupted. So unfortunately, we may have to go look at our own reader code to determine, like call our own reader code and see what happens. Which, actually, can we do that? By the way, let's do a Hail Mary first. Who knows? Maybe it's right. It's not going to be. Yeah. Unsurprisingly. So I think we actually can use our code, can't we? Because we've got one of these things in here, like test PNG, which we could build, and then run it on one of these things and, you know, step through a nice simple case there. I don't actually remember where that is, but I thought we had something like that. Yeah, this thing. Can we just maybe build this thing? I don't remember what that does, but presumably there's a... yeah, here it is. Right. So in theory, if we call this thing on one of the bitmaps that we, like, you know, pulled out, we should be able to like step through the code and see like if we can read it. So, because the first step would be, let's get us reading it, because that we should be able to do directly. And then we can go find out what other stuff that maybe we're not paying attention to because we don't care if the PNG is correct. We just care if it has the stuff in it that we look for. Then we can figure out what of that is not in there, and then we're done. Because then, you know, we're writing out things that can be loaded by a third-party tool, which we would like to do. That way, if an artist needs to go in and edit like one of the font bitmaps or something, or if we just want to like debug it by opening it in GIMP or something, we can do. We don't want to be the only people who can read it, right? So let's go ahead and make that happen. I'm going to do a build of everything there, and then I'm going to open up Remedy. Let's go ahead and set the debug to be test PNG. The command line arguments were what again? Okay, so Rgb and alpha out. So we just need like what's an example file in wtemp font. Oops. So we've got liberation mono like 1111, right? So there's an input otemp font, and then we just need otemp font out rgb.bmp and wtemp font out alpha.bmp. Let's go ahead and save that into our debug directory. so that we can, switch to it again as necessary. Loading up. There it is, right there. Test PNG. So running it, we should get, okay, so great. We error out, which is exactly what we want. So hopefully we can just now step through here and let's see how far we get. Oops, I was meant to step into that. Parse PNG. Here we go. So in here, we're going to load the header. Let's take a look at the header, see what it says. Chunk header. There's the iHeader chunk. It's backwards because Indian swapped, remember, from what we would normally think of it as. We're going to consume the chunk footer. We're going to look at this and get all that garbage. Looks like that's all printed out for us. Hasn't been flushed yet, though. So let's look at it ourselves. Here's iHeader. The width and height, the bit depth, the color type, that all looks good. So we think it's supported, and that's good. So now we're going to go here and see the Idot chunk, hopefully. Let's take a look at that chunk header and just see what the size is. That looks okay. This should be the end chunk, and we should now be done. So now we're going to start consuming stuff. There's an Idot header that comes first. So let's take a look at what that looks like. Oops. No! Okay, there we go. Idot head. We've got a zlib method flags of 8 and an additional flags of 0. I think that's what we want. Yep. And now we'll come through here and try to allocate memory for everything. That should be trivial because the width and height looked fine. We read the first chunk, so we're going to load in bfinal. What does it say? It says 0. That's totally wrong. I wanted it to be 1, so I guess that's a screw up. So that's the first thing we need to go fix. And then we're going to consume btype. I think I forgot to write that entirely. So let's go fix that. And then we'll restart. So looking back at our nonsense here, I'm going to go ahead and say that that argues for 01 as the stream byte. In here, then we've got, what is it, another, what do we consume for B type? It's 2 bits. So for some reason, the type here is 2 bits. So, who knows? I guess, this is actually, let's just call this what it actually is on the other side, right? So right after bfinal, we actually need btype to be written as well. So we need, to keep this going here. So this stream byte thing, that's bfinal, and that's btype. And in here, we just need to now write that one out as an additional value. Okay. So let's save that off and rerun the program, because remember, we have to actually run the thing to update those PNGs before we try to debug again, because otherwise they won't actually have been changed. So let's jump now directly down here, since we suspect most of the other things are working so far. Let's go ahead and consume bfinal, and we want that to be 1. It is. That's good. Let's consume btype. We want btype to be 0. It is. We now need to... Oh, but wait. This is just totally not correct. Why did I freak out there? This is 1 bit and 2 bits. I'm just an idiot. I did it right the first time. So that was not incorrect. I'm just an idiot. So it's actually that. That's what's supposed to be, right? So no, I was not. I was right that this has to be changed, but I shouldn't have changed that other part. Okay, so let's do that again in a less stupid way. So let's go ahead and step through here now. Again, B type and B final should be 1 and 0, and they are. It should now flush to the end of the byte, which is why, again, I was saying these are bit level values, not byte values. Let's see what the len value is that we read in. Let's see what the nlen value is that we read in. Those are okay. We now have to put that out, put that source out there. I'm going to have to actually jump forward to here. Oh, there's not a, oh, there is a run to cursor. Does that work? Oh, nice. Okay, great. That doesn't make a lot of sense, does it? Oh, so this is not encoded the way I thought it was. What? If you have a len, all right, so I see what I did wrong. This loop is actually totally weird. It's not just let me grab some specific amount of data. It's a little bit more confusing than that. So we do a while length here, and we actually read in. So we say this just allows us to clamp so we don't actually read outside the boundaries. But then we actually consume that much data, however much we wanted here, and I guess we're just using, well, no, I guess that is what that's doing. So like, what happened there? Why did I'm gonna reset that. So what happened? Something weird happened there, I don't understand. So it was just what I thought it was, but for some reason something weird happened. So if I come through here, I've got a len, of 6216, right? I set use len. To be that. We consume that much, right? That's gonna like copy all this stuff. And then when we get to the end, this is not gonna go down like at all. Right? What happened? Was this even working before? Did we screw up this code path? I mean, look at that. How is that possibly right? I mean, there's just no way that's right. That code has to look like this, doesn't it? Where's that at? That code has to look like this. Right? I mean, it's gotta. There's no way that could have been correct. I argue. Yeah, that's what it should do, right? Maybe I'm wrong about that, but I think that's correct. All right. So it looks like we still have a problem here, which is that we didn't end up at the destination where we thought we were gonna. So we're a little bit off. Like we didn't fill all the pixels that we thought that we should, right? So whatever that len is, the len does not appear to be correct for the number of pixels that we thought we had. So, for example, like it was what, 6216 or whatever? Oops. But that does seem correct. Oh, but we need to leave room for the filter. Because every row has an additional value stuck in it for PNG. Right. I'm actually starting to remember how this works now. So every row has that, that thing that's at the start of the row that says which filter mode it uses. Specifically, filter mode 0 is what we want, which is to say that you don't have to do anything to the pixels, but you still need that on every row, even if you're not compressing. And there's no way to tell it not to do that. So we actually do need a thing here that's going to actually, this nonsense. And in fact, that kind of makes me want to write these out in a way that would allow us to do things a little bit better anyway. So for example, excuse me, we could just move this for loop, widen this for loop a little bit later, and then not actually have this problem. So, okay, so that might be fine. All right, so let's just cheese this out for now, though, and then we can play with it a little bit more. So I'm going to go ahead and do a thing here that actually writes the oops, that writes these out in a for loop, just for a second. So this is the y. We're going to go through the entire thing, writing out the pixels here, and we're going to write those out as width times 4, right? So we're going to write out those in rows. And each time we do, before we do, we're going to write out, like, basically a garbage byte, right? That's just a, like, no filter. So we're going to say, like, write out no filter, then write out this, the pixels for that row. And that's actually going to be the data that we use for pixels. And then we can broaden this out and make it so that we write like one row per IDAT or something that allows us to have arbitrarily large images. So that seems fine to me, and that would get us out of the business there, hopefully, that would get us out of the business of having to insert those into the image or something weird like that, because that way we just write them out like interleaved with the filtering mode. I think that would do it. The only problem there is, well, actually I don't think there is a problem there. I think that's it. Right? All right. So there's that version. Now let's try this again and see where we end up. I don't know where did we end up? There we go. So we still look like we're underflowing here somewhere. Looks like we're underflowing in the actual chunk read loop. Did I mess up the size calculation there somehow? I did. There we go. Okay, let's see here. This should now actually fill the length and hopefully stop at the correct place. Let's see if it actually does. There we go. All right, so now we can look and see if our reader can at least read our writer, which is a good start. Let's see. No, it doesn't look right, right? I don't see the data there. So we're still screwing something up there, right? Although I don't know, maybe we may have improved the usability of this in terms of errors in the stream, though. Nope, not quite. So we're still a little bit off, but we're getting closer. All right, so I'll leave it there, and we will go to tomorrow. We'll do the debugging, but we should be able to get it working. That's mostly everything, right? So now we just have to go through and be a little bit more diligent about actually getting all of the stuff written out properly. So I'm sure there's just some stupid stuff that's happening in here. Oh, for example, every time we write out a line, we have to advance this. So this is actually whatever the pixel pointer is. Actually, pixels is 32-bit. Yeah, okay, so I can just do this. It's actually got to do that. So that may actually have been the majority of that bug there. Let me double check. Let's just see. See if that improved anything. Does not appear to have. But you saw what the bug was there, right? Like we were writing out rows, but those rows were not actually didn't actually advance. So we have to make sure that we move the pixel pointer forwards each time that we actually write it, right? In order to have anything show up in the file. Why we don't see anything, I'm not sure, because it looks like we are actually processing that stuff out. But for some reason, we're not actually seeing any data there, not even garbage. So something is still a little bit off in the way that data is being pushed. Just trying to think if there's anything stupid we're doing there. I don't think so. That seems mostly correct to me. All right. So like I said, I'll go ahead into the Q&A and then we will wrap it up. Looks like Insobot still doesn't listen to me on that. It never likes to listen to me on that channel. I have to do it on the Handmade Network channel. IN footer is missing some swaps. Ah, yes, you're right, it is. Unfortunately, that's not our problem. Spatial free. I love that vertical header peak in your 4-code editor. Is it a default feature? How can I get it? No, I wrote that myself. I don't know when or if how that would be available more broadly. Is the RGBA the same for bitmaps and PNGs? I don't remember. I think the answer is no, but I just don't recall. In this particular case, we literally don't care because it's monochrome. So we don't have to actually know. But we did have to know when we actually did it originally. Well, you know, the easiest way to tell would just be to look at our code. So here's the test PNG code. Yeah, it's got swap R in there. So I think they're swapped. So BMP is swapped from PNG. Do you think machine learning can be useful in games? If yes, in what way? I guess I'm not sure. Like, I mean, yeah, I'm sure there'll be some things you can do interesting with it, right? The problem is I don't know to what extent you really want learning in games, you know? Like I would think it would probably be something that's more used like offline. So like, you know, you might use machine learning algorithms like outside of the game to generate stuff for the game. But then you would probably not really want to do a lot of machine learning at runtime because one of the things that makes games fun are that there are like simple, understandable patterns that players can learn about how the game works. And if the game is constantly like learning and adapting, that creates a less fun. Like I don't think there's a lot of use for that in most games because most games don't want to adapt to the player. That's like unsatisfying for the player. So in a sense, I could see you wanting that in certain games where if like the whole point of your game is that you want the AI to feel more like a human. But in most games you don't. In most games you don't want the AI to feel like a human. You want the AI to feel like an AI, right? And so for most games I think you might want more of an offline learning is what you would use. And then only in those circumstances where you were trying to make the AI feel like it learned, then you could possibly employ those techniques more like at the actual time when the game is executing, right? Will we be able to get your current 4-coder with the new version coming out and maybe the sources for yours on the Handmade Hero files? So no, the problem is my 4-coder config as of like a couple weeks ago, I now just build it directly into the MollyRocket codebase, so it's not distributable anymore. I also don't know, like, I don't think I'll probably really even be using... like, it's mostly just untethered now. Like, I ended up rewriting like almost all the edit stuff to be what I wanted, and so now I can just really call my own renderer, and it's probably going to be pretty divorced from 4-coder as a code base. So you know, Alan will probably be doing a lot of the stuff that we did together. That stuff will be shipping, but I won't be shipping an editor anymore because it's just too hard for me to do that. That would be like another job. For me to try and like I'd have to start shipping my own editor basically, which is not something I'm going to do. If that makes sense, because I'm not gonna like support an editor or anything like that. Like I'm not gonna do that. So I would say that like these, you know, a lot of the stuff that you see coming into 4-coder that I made will, you know, I contributed the code back. So
that stuff should make its way into the mainline code over time. But in terms of me shipping my own editor version, that's not going to happen anymore. I see quite a lot of people moving into more program software engineering related jobs after doing some academical research, not at all focused on CE related things, physics, chemistry, etc. Do you have any experience working with people that didn't focus on coding for a long time, possibly not having any real training in it? What's the biggest difference with people that have a degree in CE or focused on programming from a young age? No, I actually haven't ever really worked with anyone. At gas-powered games a long time ago in like '99, I briefly, only tangentially, but briefly worked with someone who was an English major originally, and I think switched to CS at some point. Other than him, I don't recall working with anyone who wasn't pretty much always a programmer. Yeah, I'm sorry. I haven't had any personal experience with that. So I couldn't really say what the differences would be. Do you feel like explicit languages make people more productive compared to expressive languages? I think functional programmers program just for masturbatory purposes. So I think you're right, for starters. But I guess what I would say is it's a complicated issue. On the one hand, if you design your language to not be particularly expressive, then what you guarantee is that the programmer can't do anything too stupid, right? If you're going to program in straight C, it's pretty hard to make a program that's that bad at, mapping to the CPU, because you have to work pretty hard to create ridiculous crap, right? On the other hand, in something like, ML or something, you can type probably 10 lines of code and create something that is impossible for a normal CPU to run efficiently, right? So there's definitely something to be said for thinking about the degree to which your language allows programmers to create things that are simply bad for a CPU. So you're not wrong. That does exist. The problem is that you do need ways for experienced programmers to use less code to create more complex things that they have specifically thought about how they should work and have a good idea for, right? C is too inexpressive to allow those programmers to be efficient. And so you ideally want something that's kind of in between the two that no one's made yet, but maybe someday someone will, that's kind of like, hey, this language is still very good at expressing things that CPUs should do and saying how they should do them, but it also allows the programmer to start lofting up those concepts into more complicated instructions that allow the compiler to do a lot of the things that the programmer would have had to have done by hand that are just rote, and that it doesn't need, the programmer doesn't need to specify how they happen every time, right? You've talked in the past about understanding the trade-offs in software development, such as optimizing, increasing complexity, time constraint in the context of readability versus features implemented. Are there other things you keep in mind when deciding how to spend your time? Not really. I'm not a particularly good programmer as far as spending time on the highest priority stuff. That stems largely because I'm too interested in solving problems a lot of times.
which I don't really think is a bad thing. It just means that like I wouldn't necessarily take my advice on prioritization, right? I think you want people who tend to go off and try to sell, like the concept of yak shaving, right? I think actually you really want people who like to do yak shaving, but you only want the ones who come up with something at the end, right? So the reason that a lot of times I think stuff like, you know, going down rat holes gets a bad name is because the people who go down rat holes never actually do anything down in the rat hole. So they just wasted their time, right? Whereas people who actually rat hole on stuff and then come up with a new way of doing things that's really awesome, those people I think are pretty valuable. And so I think, you know, it's worth drawing that distinction. But in general, I wouldn't say that you want people who are good at like rat holing and coming up with something really cool at the end of it. Those people are not necessarily the people you want giving advice to the rest of the team about like where to spend their time, though, right? So I think I'm a bad person to ask about that, because I'm more of an R&D kind of person and I like to do those sorts of things. But you know that you only need so many people doing that, and you only need people who actually come up with something when they go do stuff. You don't really need people doing that who just waste their time, right? So that's, I think, probably how you would draw, you know, how you would talk about that distinction. Yeah, George, I don't know when yak shaving became a thing. Rat holing was kind of more the phrase that I used to hear around that, but yak shaving kind of, I assume, because it's kind of trying to talk about a slightly different thing. So, you know, rat holing's like, oh, I gotta, you know, do this PNG writer, and then I end up like spending a ton of time like researching the origins of PNG and how they worked and whatever. So you know, yak shaving is kind of a term that came up to sort of talk about something a little bit slightly different than that. I mean, you don't really need another term, but you know, it's worth noting that there's a different thing there. And so what yak shaving is trying to refer to is like the concept that in order to do something, you kept having other things you needed to do first. And so someone comes in, like, you know, 2 weeks ago they were like, we need you to write this PNG reader or writer. And then 2 weeks later they come back and you're working on like a new device driver for the hard drive, right? Or something, right? And they're like, what happened? And you're like, well, you know, I started writing the PNG writer, but then I noticed that there were these problems when I was actually writing the things out. I wasn't getting the performance throughput that I thought I should get. So then I started profiling the hard drive, and I realized that the hard drive was like writing things really slowly and not exactly the speed that it should have been. And so then I looked at why that was happening, and it turns out that, you know, blah, 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 blah. The reason they came up with the name yak shaving is because it's like, they told you to write a PNG reader, and they come back in 2 weeks, and they see you just like shaving a yak. And you're like, what are you doing, right? And so it's just this notion that like from something that should have been relatively straightforward, they came back and found you doing something totally unrelated to anything, but you have some coherent explanation of like how you went through the steps that actually got you there, right? We don't use libraries on the stream. Everything has to be written from scratch. So you could certainly use STB image or something else to write a PNG, but you know, the whole point of the stream is to show how to write code. If all I show you how to do is download a library, well, bad news, folks. You'll be replaced by AIs in about 10 years. The AI that just uses Stack Overflow and cut and pastes the code is going to replace like 90% of programmers in 10 years. I guarantee you it's coming. Because like
a lot of people who are, nominally programmers these days are just a glorified cut and paste engine, and they really don't know how to do anything other than like pipe libraries together and cross their fingers. And that is going to be automatable. I mean, we're already getting to the point where programming systems are going to be able to understand APIs and wire them together. That's not going to be that big of a deal. And so I think they're going to get there. And so the only programmers I think that'll be all that useful are people who actually know how to do something, at the lower level. So I try to teach as much as possible how to do that, because I think those are the only programmers that are going to remain valuable. People who are literally just like wiring stuff together, I just don't think they're going to be necessary. If you go back and look at sort of what happened as robots automated away manufacturing, there's just not as many people necessary to build stuff anymore, and that's going to be true of programming, right? As soon as people start automating it, huge swaths of people who are literally just the dude who puts the bolt on the thing, which is like the equivalent of like, I went and looked on Stack Overflow and then I used like 15 packages to print a stupid integer or something, right? Like, those people are just gone. I mean, there's no why, you don't need those people for anything, because they're not doing anything, right? They're just doing what an AI could do. And I think, I don't know what percentage of programmers that is, but it's pretty high nowadays, because there's just, in the 80s or something, the percentage of programmers who were doing something like that was incredibly low. Today, I think the percentage of programmers that are doing that is very, very high, because there's thousands of programmers working on things like Twitter, which is, a very minor program or something like that. And so you're just like, what are all these people doing? They're not doing like, all kinds of hardcore, super amazing programming where they're doing just the stuff that you can't possibly conceive of how an AI could ever do it. It's like, that's not what's happening, right? And just the number of them that there are, there aren't that many good programmers, right? It's just not the case. And so at some point, I think that huge slack just gets optimized away, because there's really just no need. I mean, you just don't need people who are just pushing libraries around. There's no point. The people who are interfacing with those programmers will simply skip the programmers and use some kind of automatic generative tool to produce the combination of stuff that they want, and they won't need a programmer in the loop at all, right? And so then the only people I think that will still be around are the people who are creating like new stuff, the engine maintainers, the people who are writing new languages, the people who are working on those AIs. I think that's really all you got left, because you just don't need people who are just reconfiguring existing code. Reconfiguring existing code to do something else that code could have done, but that no one had actually piped together in a particular way, that AIs will have that under control. That's my prediction anyway. And the only reason I say that is because that's what happens to every other industry. So it's kind of, I don't know why it wouldn't happen to ours, right? Everyone probably always thinks that their job is the one that only they could do. And, of course an AI can't do my job. It's like, well, really? Every industry that has no robots in it eventually gets to be some percentage robots. You really think ours is going to be 0%? It's a pretty big wager. There's too much stuff in here. My voice is getting sore. Yeah, well, I've read the sequel. I mean, if you want a really future-proof job, I would work on code gen, man. I mean, because that's that's where I think it's going, I would either specialize in something that's going to be very hard for AIs to do, like maybe operating systems development, hardcore engine programming, that sort of stuff. That'll probably be like further, it'll be later. It'll take longer to automate those away. Or I just get on the automation bandwagon and say, I'm going to make the stuff that replaces the, 50% of programmers who are just Googling Stack Exchange and then cutting and pasting crap and just making piles of crap. And be like, I'm going to make the crap pile program. And you can just give it these high-level directives and say, make me a crap pile that does this thing. And it's like, how about this? And you're like, sure. Probably got less bugs than the people we're replacing would have put in there, so off we go, right? Because I just don't see any way that probably 90% of the web things I interact with, I don't see any way those couldn't have been made by an AI, right? The code for Gmail could have easily been made by an AI, and it would have been better than the code that is up there now, right? Just the front end, right? Or the more much easier than that would be like something even simpler. The web page for my bank, my credit card company, right? It's just garbage, right? It could have taken a very high level directive of what that page looked like and generated that code, right? And it would have just spit out the same stupid jQuery garbage into a giant bloated web page that takes forever to load and is slow, but guess what? That's what I'm using right now. So how hard is that? Could that AI possibly be to make, right? And so I feel like all that stuff is super automatable now, and it just isn't because no one's doing it. But I think you could easily do that, and then you could just go around to like every bank and say, here you go, here's the web page, here's the entire web front end maker for you, and you don't have to do anything else, right? And then you can just keep growing it from there, and it's like, oh, let's add restaurant websites, let's add this, let's add that, right? And people are already sort of doing a version of this, like Squarespace or something like that, that's just like use templates, right? How hard is it to go from that to whatever the rest of the stuff is people normally pay programmers to do with their back end, right? You know what I'm saying? Like, it can't be that hard to just start extending those template-y based things to just having some AI that's like, hey, now I can just make my own stuff. I don't need to do, like, it doesn't have to all be templatized, right? It can actually think a bunch about how to, like, combine multiple things together into making a new thing. And then you just, off you go, right? So I don't think you need most of the programmers who are doing those things. I think you could just get rid of most of them, right? By just starting to build things that do the modicum of actual real work they do, just do it automatically. I just don't think that's going to be that hard. Do you have a standard vector dynamic array replacement, aka are you also not using standard? We are not using standard for anything. In fact, we do not include any standard library stuff from the C++ side of things. We don't use any dynamic arrays, though, either, I don't think. So we never wrote a replacement for standard vector because we just don't use standard vector semantics anywhere anyway, if that makes sense. I wish you used C99 with MSVC, but heard it is not so well supported by Microsoft. Could it be an issue for programming in C with Windows? I don't know. I thought MSVC now supports C99 pretty well, actually. But what I would say is Clang works on Windows now. Totally fine, right out of the box. You can just go download Clang for Windows, and it supports C99 and every other flavor of C you might want, and it outputs PDBs and XZs in native window format. So you can just skip the whole MSVC thing if you want to, I guess is what I would say. I mean, okay, so guys, here's another thing. Just make your AI, anytime it can't figure something out, just make it post to Stack Overflow and wait for someone to answer the question, right? I mean, again, that's what a lot of programmers do. They just they don't know how to do even basic stuff, so they post on Stack Exchange and they wait for a programmer who actually knows what they're doing to tell them. So just do that. There's an AI. That's a sellable AI, right? Just make an AI. It tries its best to solve the thing that you ask it to do. Any step it doesn't know, it posts on Stack Overflow the question. If someone closes the duplicate, it looks at the one it was told to look at and tries to grab the code from there and roll it in, right? Get working on it. Do it. Right? I mean, Insobot will be there soon. All right, I'm gonna call it quits. Some guy on Twitch is writing a VIM plugin that you ask questions to and it would look on Google or in a database for code and paste it in on your cursor. Yeah, I mean, right? Because there's plenty of things that are just too complicated and that's not going to work for. But a lot of those things aren't things that programmers are being asked to do, right? I mean, you're talking about like FizzBuzz as an interview question kind of nonsense. That's the bar we're talking about for a lot of programming jobs. There's no way you couldn't make an AI to replace some of those jobs. I mean, there's no way. Like, we will make those AIs. We just haven't figured it out yet, but we will, right? And yeah, just like make the thing have the ability to post questions to the internet. Like, that's part of the AI. It can ask to see if other people will post code for it, right? Do it. Get started. Someone will make it, and, you'll be doing the world a favor because we won't be having sort of this weird layer of programmers who aren't really programmers or whatever, who are kind of clogging up the economy by sucking down huge amounts of money, which then creates income inequality for people who are really not doing anything that couldn't have just been done by a robot, right? So it would be nice to just kind of even that out and not have there be so many really high paying jobs in this weird concentrated sort of situation. Another way to say it would be, it helps create a world where everyone's in the same boat if there aren't magically a few jobs that can't be automated, right? Because as long as there's a sector of people with unautomatable jobs and then everyone else has automatable jobs, you're just gonna the money funnel just points straight at the people with the unautomatable jobs, right? And so you just that's just not a good recipe for stable society. Having a bunch of people who can make infinite money and then a bunch of people who can't make any is not going to be great, right? So the sooner we have everyone afraid that their jobs will be automated, probably the better. I feel like that's a good idea. And so the number of programmers who were around in the 1980s wouldn't create enough of a disruption. So if you could even just, you don't have to automate all the programming jobs, just automate 50%, right? Automate 75%. You don't have to automate 100, right? But just get it up there, and that's good enough, because that creates the fear and that puts everyone into the same mental category. Because, I mean, not all manufacturing jobs are automatable either, right? There are still people working on assembly lines. So you don't have to be 100%. Just make sure that they don't feel like they're untouchable by the wave of automation. Make sure we're all a little bit worried about that, because then we will all probably, hopefully, I mean, maybe this is assuming too much for humanity, but assuming that most people are in the same boat, then they will presumably act together more than if you have a hard delineation between like a large number of people who don't have to worry about this thing and then another large number of people who do. Haven't thought that through particularly well, so take it with a grain of salt, but it just seems like we want automation to be everywhere, because since it's going to be certain segments quite a bit, we probably want to make sure it's going to be everywhere so that people are affected more uniformly and will want to take steps to make sure that society doesn't like implode as a result. All right. Okay, thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code so you can play around with it. We mostly made the PNG writer today. We just kind of slopped it in there, but it's probably mostly done. So one good exercise you could do over the weekend before I do it tomorrow morning is go debug why it's writing out the stuff incorrectly and get it writing correctly. That would be one thing you could pretty easily do that would be a fun exercise, right? Because we've got the whole structure there, so now you just got to go look at it and see what it's doing wrong. So I would recommend giving that a try if you're up for doing some work today that might be educational to you, if you're the kind of programmer who's still working on stuff like that. Obviously, if you're an expert, this is nonsense what I'm saying. But if you're interested in some beginners kind of stuff to do, try debugging that. That would be a good exercise. I'll be back tomorrow to debug it myself, and then we can see what was wrong with it all together. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody, and I'll see you tomorrow.